Hello students, welcome back to the science class. In our last class, we have discussed some concepts of sound. In this class, we will discuss some more concepts of sound. Okay? Students, let us now discuss characteristics of a sound wave. We can describe a sound wave by its frequency, amplitude and speed. A sound wave in graphic form is shown in figure 12.8c of a book, which represents how density and pressure change when the sound wave moves in the medium. The density as well as the pressure of the medium at a given time varies with disturbance above and below the average value of density and pressure. In figure 12.8a and figure 12.8b, they represent the density and pressure variations respectively as a sound wave propagates in the medium. Compressions are the regions where particles are crowded together and represented by the upper portion of the curve. So students, let me draw the figure of the sound wave as it is given in your book, and then we will discuss about the properties. Fine. Students, I have drawn the figure as it is given in figure 12.8c of your book. The peak represents the region of maximum compression. Thus, compression are regions where density as well as pressure is high. So, peak means the highest point. So, the peak represents the maximum compression. Then, as per the particles movement, they come, they go down and they again go up. That means the valley that is below the straight line, the valley that is your rarefaction. So, compression and rarefaction, compression and rarefaction and so on. The peak is called your crest and the valley that is called your trough. Okay? Students, the distance between two consecutive compression. In this diagram, see, this is a compression, this is another compression. So, they are two consecutive compression. The distance between two continuous compression, which are the continuous compression, this one and this one. Okay. Suppose this is x, this is y, compression x and compression y. So, distance between two continuous compression, and suppose this is rarefaction m and rarefaction n, or the distance between two consecutive rarefaction. M and n are two consecutive rarefactions, x and y are two consecutive compression. So, the distance between the two consecutive compression or two consecutive rarefaction is nothing but called the wavelength. Okay, as you can see here, or you can refer the diagram 12.8c. Wavelength is represented by the symbol lambda, that is nothing but a Greek letter. Okay, its SI unit is meter because we are referring to the distance. Okay, we are referring to the distance. So, its SI unit is meter. From this, we understand that wavelength is lambda and its SI unit is meter. Hope you understood this. Students, frequency tells us how frequently an event occurs. Suppose you are beating a drum, dum 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 dum. How many times you are beating the drum per unit time is called the frequency of your beating the drum. Suppose I beat the drum 20 times per unit time, so my frequency is 20. But you can beat the same drum 30 times per unit time, so your frequency will be 30. As simple as that. It is the number of time an event occurs per unit time. We know that when sound is propagated through a medium, the density of the medium oscillates between a maximum value and a minimum value. The change in density from the maximum value to the minimum value, again to the maximum value, makes one complete oscillation. Maximum to minimum again to the maximum is called your complete oscillation. The number of such oscillations per unit time is the frequency of the sound wave. If we can count the number of the compressions or rarefactions that cross us per unit time, we will get the frequency of the sound wave. It is usually represented by V, Greek letter nu. Its SI unit is hertz and its symbol is hertz. Okay. Heinrich Rudolf Hertz was born on 22 February 1857 in Hamburg, Germany, and educated at the University of Berlin. He confirmed J.C. Maxwell's electromagnetic theory by his experiments. He laid the foundation for future development of radio, telephone, telegraph and even television. He also discovered the photoelectric effect, which was later explained by Albert Einstein. The SI unit of frequency was named as hertz in his honor. Okay? Students, the time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of the wave. In other words, we can say that the time taken for one complete oscillation in the density of the medium is called the time period of the sound wave. Okay? Time period is represented by the symbol T. So, time period is T and its SI unit is second. Fine. So, frequency and time period are related as follows. It is V is equal to 1 by T. So, frequency and time period are inversely proportional to each other. Frequency and time period, they are inversely proportional to each other. A violin and a flute may both be played at the same time in an orchestra. Both sounds travel through the same medium, that is air, and arrive at our ear at the same time. But both sounds travel at the same speed irrespective of the source. But the sounds we receive are different, isn't it? The sound of violin is completely different from the sound of the flute. This is due to the different characteristics associated with the sound. Pitch is one of the characteristics. How the brain interprets the frequency of an emitted sound is called the pitch. The faster the vibration of the source, the higher is the frequency and higher is the pitch. Okay, as it is shown in figure 12.9. Thus, a high pitch sound corresponds to more number of compressions and rarefactions passing a fixed point per unit time. Okay? Objects of different sizes and conditions vibrate at different frequencies to produce sounds of different pitch. The magnitude of the maximum disturbance in the medium on either side of the mean value is called the amplitude of the wave. It is usually represented by the letter A as shown in figure 12.8c. For sound, its unit will be that of density or pressure. So, your amplitude will be is denoted by A. Fine. The loudness or softness, see, louder and softer. The loudness or softness of a sound is determined basically by its amplitude. So, the amplitude of the sound wave depends upon the force with which an object is made to vibrate. See, hello, that means I am giving much force. Okay, I am giving much force. The sound is louder. Hello, hello. That means I am giving less force. So the sound is softer. If we strike a table lightly, we hear a soft sound because we produce a sound wave of less energy. If we hit a table hard, we hear a loud sound. Students, see, this is a scale. I strike it lightly. See, it is producing a soft sound. If I increase the force, so sound becomes louder and louder. Again, if I decrease my force, the sound becomes softer. Okay, hope you understood this. Loud sound can travel a larger distance as it is associated with higher energy. When the sound gets more energy, it travels more distance. A sound wave spreads out from its source. As it moves away from the source, its amplitude as well as its loudness decreases. Figure 12.10 shows the wave shapes of a loud and a soft sound of the same frequency. Okay? Students, you can go through the diagrams. What you observe in the diagram of the soft sound? The amplitude of the sound is less. But in case of the louder sound, the amplitude is greater. So, greater the amplitude, louder the sound. So, when I speak loud, that means the amplitude of my sound is greater in comparison with the amplitude of sound when I speak soft. So, in this case, my amplitude is lesser than the amplitude of sound that is I am producing now. Okay, hope you understood. You can practice this diagram or you can just revise it again and again so that you can feel the difference. Fine. Students, the quality or timbre of sound is that characteristic which enables us to distinguish one sound from another having the same pitch and loudness. The sound which is more pleasant is said to be of a rich quality. A sound of single frequency is called a tone. The sound which is produced due to a mixture of several frequencies is called a note and is pleasant to listen to. Noise is unpleasant to the ear. Music is pleasant to hear and is of rich quality. We always experience such things. See, whenever we listen to music, we feel pleasure in our heart and mind. But when we are stuck in a traffic jam, the noise of the traffic, it creates an unpleasant mood of ourselves. So, in this way, we have discussed many characteristics of sound. Now, let us discuss some questions. Okay? Students, question 1. It says, which wave property determines loudness, pitch? So, what should be the answer? Loudness. It is determined by the amplitude of the sound. As we have already discussed, greater the amplitude, more will be the loudness. So, answer should be loudness is determined by the amplitude of the sound. Greater the amplitude, more will be the loudness. Bit B about pitch. Pitch is determined by frequency. Higher is the frequency, greater will be the pitch. Question 2. It says, guess which sound has a higher pitch, guitar or car horn? What should be the answer? It should be guitar because it produces more frequency or it produces higher frequency than the car horn. So, your answer will be guitar. Okay, hope you understood this. Students, let us now discuss about the speed. The speed of sound is defined as the distance which a point on a wave such as a compression or a rarefaction travels per unit time. So, speed v is equal to distance by time. We know v is equal to distance by time, that is in this case lambda by t, where lambda is the wavelength of the sound wave. It is the distance travelled by the sound wave in one time period t of the wave. Thus, is equal to nu or q1 by t is equal to nu, or we can say that is equal to lambda nu. Fine. That is, speed is equal to wavelength into frequency. Speed is equal to wavelength into frequency. The speed of the sound remains almost the same for all frequencies in a given medium under the same physical conditions. Hope you understood this. We will discuss about example 12.1. It says a sound wave has a frequency of 2 kHz and wavelength 35 cm. How long will it take to travel 1.5 km? Okay. So, let us now discuss the solution. What are given? Given frequency is equal to 2 kHz, that is 2000 Hz. So, frequency, that is 2 kHz or 2000 Hz. Fine. Wavelength lambda is equal to 35 centimeter, or we can say 0.35 meter. Fine. We know that speed of the wave is equal to wavelength into frequency. So, is equal to okay, and that is equal to 0.35 meter into 2000 Hz. Okay, and when we calculate, it will come up to 700 meter per second, because it is speed. Okay. So, the question says how long will it take to travel 1.5 kilometer? Fine. So, we have found the speed, that is 700 meter per second. So, now we need to find the time for travelling 1.5 kilometer. Okay. So, the time taken by the wave to travel a distance d of 1.5 kilometer, we need to find it. The speed is equal to 700 meter per second, and the sound is going to travel for 1.5 kilometer, that is equal to 1500 meter. Okay. So, to travel 1500 meter, it will take 1500 divided by 700, which will be 2.1 second. Okay. So, the sound will take 2.1 second to travel a distance of 1.5 kilometer. Hope you understand. We just need to follow some general formula to find out all the solutions. Okay. So, just concentrate and just go through the book to find out the actual solution for every problem. Okay. There are few formulae which we need to follow. So, nothing to worry. Students, let us now discuss some of the questions those are given in your book. Okay. First question says, what are wavelength, frequency, time period and amplitude of a sound wave? Okay. Let us discuss the answer. Let us first discuss wavelength. The distance between two consecutive compressions or rarefaction of a wave. It is called your wavelength. Its SI unit is meter. Okay. What is frequency? One compression and one rarefaction constitutes one vibration. The number of vibration in a second is called frequency and its SI unit is hertz. What is time period? The time taken by the wave to complete one oscillation, that is the time between two consecutive compressions or rarefactions is called time period. What is amplitude? When waves are produced, the particles vibrate about their mean position. The maximum displacement from its mean position of a particle is called its amplitude. It is measured in meters. Hope you understand the solution. Now let us go to the second question. It says, how are the wavelength and frequency of a sound wave related to its speed? So let us discuss the answer. We know speed is equal to wavelength into frequency, or V is equal to lambda nu. Okay? Question number 3 says, calculate the wavelength of a sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. So let us discuss the solution. Okay? So here F is equal to 220 Hz, fine, and speed 440 meter per second. Okay? We know that wavelength is nothing but by F, that means speed, that is 440 by 220 is equal to 2. So the wavelength of the sound is 2 meter. Hope you understood. Students, let us now discuss about loudness and intensity. Okay? The amount of sound energy passing each second through unit area is called the intensity of sound. We sometimes use the term loudness and intensity interchangeably, but they are not the same. Loudness is a measure of the response of the ear to the sound. Even when two sounds are of equal intensity, we may hear one as louder than the other simply because our ear detects it better. Now, let us discuss a question regarding this concept. It says, distinguish between loudness and intensity of sound. Now, let us discuss the solution for this. Okay? Students, loudness and intensity both depend upon the amplitude of sound, but loudness is the physiological response of our ears to a particular frequency. Our ears are more sensitive to some frequencies as compared to others. Intensity is the amount of sound energy passing per second per unit area. It is proportional to square of amplitude. Hope you understood the solution. Students, let us now discuss about speed of sound in different media. Sound propagates through a medium at a finite speed. The sound of a thunder is heard a little later than the flash of light is seen. So, we can make out the sound travels with a speed which is much less than the speed of light. That is why when there is thunder and lightning, we see the lightning first and after some time we hear the thunder, because there is a speed differentiation. Speed of light is much more greater than that of speed of sound. So, the speed of sound depends on the properties of the medium through which it travels. You learn about this dependence in higher classes. The speed of sound in a medium depends also on temperature and pressure of the medium. The speed of sound decreases when we go from solid to gaseous state. In any medium, as we increase the temperature, the speed of sound increases. For example, the speed of sound in air is 331 meter per second at 0 degrees Celsius and 344 meter per second at 22 degrees Celsius. The speeds of sound at a particular temperature in various media are listed in your book in table 12.1. So, you need not to memorize the values, but you should remember the values and you can use these values in some of the numericals. Okay? Students, with this we end today's session. In today's class, we have discussed many other concepts of sound and we have gone through some question answers. You just go through the book, revise all the concepts and revise the answers of the question which we have discussed in this class. Remember, the more you practice, the better you be. Okay? So keep practicing and keep smiling. Thank you.